Yeah. So we are going to continue from where we. I'm sorry. I think I'm still not able to share the screen, right? So you're able to see the screen, right?
Yes.
Okay, cool. So I'm going to continue from where I left off yesterday. So just to recap, we talked about various VPC components, and mainly we talked about routers, how route table helps in you know um, identifying the target and routing the traffic to the uh, target, and how we can assign an elastic IP to the instance or elastic network interface, and why the NAT gateway and the NAT instances were used. So basically, where the NAT gateway was placed uh, in a public subnet, and how the private instances in a private subnet can connect to internet through NAT gateway. And we also or try to understand security groups and network ACL. So these were the firewall provided by VPC, and we understood that the security group are at instance level, and network ACL are at VPC level, which are connected to subnets. And we also understood uh, how internet gateway are placed, and how it communicates uh, with the components, with the resources in the VPC, how it does the network address translation and maps the public IP address with the private IP address. And uh, we also looked upon the flow logs. So we are gonna today we are gonna understand peering connection, and some of the other means of connecting to other means of connecting from remote systems, or corporate data centers to the VPC, uh, and how we can also connect to different AWS services without going to the internet. So let's get started with what peering connection means. So so peering connection is like whenever you want to connect to VPC um, in a way that it should communicate each other using private IPv4 addresses or IPv6 addresses, then we go ahead with peering connection model. And basically you can have this peering connection within your account, or you can also have a connection between two VPCs with another account, and you can also have VPC connections between different regions within your account. So all these are possible with a certain restrictions. So we will talk about valid configuration, and some of the invalid configuration as well. So here's an example of two VPCs peer together. So you can see that the CIDR range of VPC A is 10.0.0.0/16, and VPC B is 172.31.00/16. So each are connected, the both VPC are connected through a device or a virtual device called VPC peering connection. This uh, will connect, this will help us in establishing the connection between the two VPCs by, first thing is it will, whenever you create a VPC peering connection, it will ask for the requester. uh, let's say VPC A is trying to request to connect to VPC B, then it will register VPC A as a requester and VPC B as acceptor. And one, if the both VPCs are owned by you, then you just have to go to this VPC peering connection um, console, and you just have to accept it. Otherwise, if the VPC is part of a different account, then the account holder has to accept the peering connection. So there are two things that has to be done to establish a connection between VPC A and VPC B. First thing is requesting between the two resources, and the next thing is we need to add a route table entry in both VPC A and VPC B. So these captures the destination target information of the peering connection. So what it means is, for an example, in VPC A, route table has the CIDR block of VPC B, and VPC B has the CIDR block range of VPC A. So this actually shows that destination is for VPC A who is having 172 CIDR block um, are connected to VPC B. I'm sorry, I think there is a mistake in this route table block. The VPC A and VPC B has to be interchanged. So VPC A actually owns 10.00 10.00/16, but here I have mentioned 172 block. So there's a mistake here, so typo here. So the first table is basically VPC B, and second table has to be VPC A. So yeah, Anil.
You can proceed actually.
Okay.
Just
So I'm just pointing out the mistake that is there in this presentation. I'm sorry how I missed it. Anyways, so there is one more restriction while you are establishing this connection. The CIDR blocks should not overlap, which means that yes, Sridhar. Yes, Sridhar. Sridhar, you're trying to speak, Benjamin? Okay, I just want to check. Let's see. Still on the call. Yeah, you're trying to call. Yes, Sridhar. Sridhar, you want to say something? Oh, I think signal is lost. Mm,
I think he got disconnected.
is it?
Looks like.
Okay. Mm, but it says is connected. Not sure why. I think he's having some trouble connecting. Not sure how I should contact him. Let's hold on for a minute.
Hey Anil, are you hearing Achal very well? Because for me there was some kind of disturbance or it was on and off.
I'm hearing him clear, Sridhar. No disturbance from his end.
Okay, something maybe spike at my end.
Okay.
Okay, let's continue.
Okay.
Yeah.
Okay. So we were, talking about peer connection and how route tables are configured for this peering connection. And so the one thing is a CIDR block cannot be overlapped. So which means that the IP, range here that we have mentioned cannot be same. And whenever we establish this peering connection, the traffic always stays inside AWS network, and if you are connecting to interregion, it will be backed by AWS global backbone. So the network never transits, um traverses in the public internet. So no, you need to understand that when we are trying to use a VPC peering connection, we can actually communicate between the instances uh, using a private IP address. So that is the reason we are trying to establish this whole connection here. So here is some of the valid configuration and invalid configuration that we are trying to exhibit. So two VPC paired together we just saw with the previous example. So one VPC paired with two VPCs is here. So this diagram depicts uh, VPC-A connected to VPC-B and VPC-C. So if you see this CIDR range, all three CIDR range are different from each other. So any connection between two VPCs are bidirectional in nature. So if you connect with peering connection, it can communicate uh, between no instance in VPC-A can communicate with VPC-B, and VPC-B instances can connect to with VPC-A. And coming to three VPCs peer together, so you can see here all three are connected, and there is an exclusive connection between all the VPCs. So if VPC B has to connect with VPC C, it has to be connected directly. So just in case if if you think that we can VPC-B can be connected to VPC-A and VPC-A can be connected to VPC-B, uh, it cannot just go via the peering connections. I mean, the traffic cannot go via the peering connection. So, yeah, this is an example of one VPC paired with multiple VPCs, and there is also a way where multiple VPCs are connected with each other, and everything has to be connected. If one VPC has talked to wants to talk to another VPC, there has to be a exclusive peering connection between them. So some of the invalid configurations are they should not be overlap in the CIDR range, um, and there cannot be a transitive peering. Transitive peering is VPC-B cannot directly contact VPC-C if it doesn't have a exclusive connection. And also, if yeah,
But it can connect through a VPCA, right? If it wants to establish connection to VPC, there's no way from B to C.
so what it means is VPC-B can connect to VPC-A, right? And VPC-A can connect to VPC-C. But if there is an instance in VPC-B and it cannot directly access VPC-C instances using private IP.
Oh, oh.
Okay, so it cannot directly contact this just because it has a connection to VPC-A. Okay, so
Yeah, okay, got it.
yeah, so it's a similar pattern with edge to edge routing through gateways as well. So if you have VPC-B and VPC-A connected through a peering connection, and VPC-A connected to S3 via endpoints, it cannot connect to S3 directly. So this is also an invalid configuration. So at the end, we saw what was we tried to establish the endpoint. So let's understand what these endpoints are really. So uh, basically, in general, any resource like S3 or DynamoDB or a few other resources which are out there, whenever you're trying to connect them, it will be routed through internet gateway. So in general, to in a regular way, right? So it has to be it doesn't make sense sometimes to have a VPC within you have within AWS network, and you also have a S3 or a DynamoDB uh, resource to be connected and to be used, and the route has to be through the internet or through public cloud. So what we could do is AWS provides a component called VPC endpoint, so we can establish the uh, resources in the VPC privately, talk to these resources with the help of endpoints, VPC endpoints. So these VPC endpoints are placed at the are at the edge of the VPC at the edge of the VPC, so that they act as a gateway um, between sorry, for the AWS resources. And there are mainly two different technologies or two different ways to you can connect to AWS resources. So one is gateway endpoints and another is interface endpoints. Gateway endpoints are basically very similar to internet gateway, but it has a route table, and which routes the traffic to only two services. Those are Amazon S3 and DynamoDB. So gateway endpoints can only support uh, Amazon S3 and DynamoDB. And if you want to connect to other AWS resources which are out there, you might have to use something called as interface endpoints. So let's learn what interface VPC endpoint mean. So basically, it's an as the diagram depicts, it's an network interface. It's an elastic network interface with a private IP, which can actually connect to many of the AWS services with a technology called AWS Private Link. So AWS Private Link is an infrastructure provided by AWS, so which helps in privately connecting VPC with it can be with on-premise applications or AWS services or any services at marketplace apartments. So basically, private link can be seen as an infrastructure. So these are some of the components that we can connect through interface endpoints. So there is if you see this in this example, there are two subnets, subnet 1 and subnet 2. I'm very sorry, subnet 1 and subnet 2. Subnet 1 established this connection to Amazon Kinesis stream through internet gateway. It has to go to internet gateway and then get connected to Amazon Kinesis stream. But since we have an interface endpoint in a subnet 2 instance, in the subnet 2 can directly connect to Amazon Kinesis stream via this interface endpoints. So there is, if you see this, there is no route table entry here. So it is basically maintained through elastic network interface. So you have to create an interface which will actually point to Amazon Kinesis stream. So there can be connections between on-premise resource to cloud in many different ways. So I have pointed out 3 different ways to connect on-premise resource to AWS cloud. One is internet. Through internet you can connect from on-premise to AWS cloud. Another way is through VPN connection. So what VPN connection means is if you want to connect any on-premise resource to AWS cloud, we can have IPsec protocol to be used, and it would be an encrypted channel which two devices can communicate. So there is also infrastructure built by Amazon called Direct Connect. So we're gonna learn how both VPN connection and Direct Connect works. So VPN connection is basically a remote network. Whenever a remote network is connecting to, as I told, there is a corporate network which is trying to connect to the VPN. It establish the connection between the two through a channel called VPN. So this is a IPsec channel. So it's a secured encrypted channel. To achieve that, we need two components on the other side. One is a customer gateway components, where it resides at the customer end, and a virtual gateway, private gateway point, where this VPN connection terminates, and the traffic is directed to the router, and router directs the traffic to the respective instances. So these two, virtual private gateway and customer gateway, are the terminating points of VPN connection. So there are different kinds of VPN connection which can be established, and they are AWS site-to-site VPN. This is a prime example of what site-to-site VPN looks like. So we will have two components sitting over here. This can be customer gateway, can be hardware or software. So but there has to be a virtual private gateway attached to um, VPN, which is virtual in nature. This is not a hardware device. So you can also see that there is for this VPN only subnet, we have a route table entry in the main table which says the target all request except this has to go to virtual private gateway. So everything from database servers comes to virtual private gateway, and everything from public subnet goes to internet. So we have mentioned the IGW literally means internet gateway, so which is here. So all requests goes through, it comes to router, and router will direct to internet gateway. So here we have, you see this public subnet and private only subnet here. So let's understand what direct connect infrastructure is all about, right? So it is again a hybrid architecture. So we have a customer network here, and we have AWS cloud here, and we want let's say we want a high-speed connection, and we want to avoid internet. So what we can do is AWS provides a direct connect locations around the world. So if there is a direct connect location placed near to our existing location or our customer network location, we can take our uh, partner router, and we have to establish from we have to establish connection from our customer network, from our network to uh, the direct connect location, and from there a router is connected to direct connect endpoint, and this direct connect endpoint will direct the request to uh, different services or VPC. So by establishing this, we will completely avoid traffic going to the public network. So direct connect is an approach where if a company compliance or policy states that it cannot go outside to the if the traffic cannot go outside to the internet, then companies can go with this direct connect approach. So basically they are dedicated private up to 10 GB PS direct connection from your from this center direct connect center to these VPCs or the services. So basically the benefits of this direct connect is um, you have a consistent experience of the network. So you don't get to see the network clogging or the variation in the network bandwidth, and it provides you the increased bandwidth. Now if you want beyond 10 Gbps, you can ask for and they will allocate as well. So it basically reduces, if you're taking net calls within the same channel, the network calls between the VPC or AWS cloud and the customer will be reduced, and the data charges are reduced as well, because yeah, Amazon charges any data transfer to the internet, and they can be avoided as well. So the most important benefit that you get out of this kind of architecture is you can communicate within the or you can communicate using private IP addresses uh, with your VPCs or other AWS resources. So to understand, before VPC, there was something called as EC2 Classic. So here you were, it was a very flat network, and instances were just created, and everybody used to share the network with each other. And with VPC, when they launched VPC, you got a very isolated private cloud, which basically logically isolates from other accounts. And uh, accounts which are having prior to 2013 still have EC2 Classic, but if you're creating any account after 2013, you don't have the option to even create EC2 Classic instances. So if in a company they have opted for uh, account prior to 2013, they might still have access to EC2 Classic. So some of the benefits of VPC or EC2 Classic are like you can assign a static private IP address to your instance. Earlier it was not possible. Now even if you stop and start the instances, the private IP will still be there till the end of life of the instance. So till you terminate the instance, the private IP address will still be attached to it. It wasn't so with Elastic, with EC2 Classic. So multiple IP address per instance can be attached now. So we can have uh, more than one private IP addresses attached to an instance. One can be primary, and you can attach a few more secondary instances, secondary IP address. So you can define network interface however you want and attach uh, to uh, to your instance. So this network interface can have many IP many public IP address attached, and it is easy to move between instances. And you get the benefit of security groups and network ACLs for both ingress and egress filtering. So basically inbound and outbound filtering. So with VPC you get the benefit of hardware support, single tenant hardware support, which means that you get a dedicated uh, uh, instance where, or a dedicated physical host uh, where the system will only have your instance in it, and that particular system or host doesn't contain any virtual servers or instances other than your account. So that can be achievable with VPC. So let's check the demo part, how VPC can be created, and let go through more of a hands-on on how VPC, how the different VPCs, and how we can create two wizards and all that. So basically, I'll be going through the options. So I'm gonna switch to the AWS console. So basically you can create VPC in two modes. So one is you can directly come here and create VPC, and there is also another option for you to create through a wizard. So let's understand what these options are. So basically the first option is VPC with single public subnet, which means that any instances that are deployed within this public subnet can directly access through internet. So as and when you create this you know this infrastructure or this kind of pattern, so you would get a network with /16 network of VPC, and the subnet would be /24. And we will understand the limitations of these networks as we dive in. And also this public subnet uses elastic IP addresses or public IP address to access the internet. So by default you can have these public IP accesses. So this is another arrangement where you have when if you go with this option, you get two subnets. One would be public subnet and another would be private subnet, and within public subnet a NAT device is created as well. And please note that these NAT devices are chargeable on hourly basis. So if you are going with the NAT instance and you are keeping it uh, without using it, or keeping it idle, then still the instance or the NAT gateway will be charged. So we saw a difference between NAT gateway and NAT instance earlier. So NAT instance is a regular instance. NAT gateway is managed by AWS. So this is highly available and highly scalable, and it is redundant. So internally you don't need to scale up or scale down, or you don't have to worry about the scalability of the NAT device itself. So this is an arrangement where this is basically an hybrid infrastructure that we are seeing, architecture that we are seeing here. And a corporate data center can directly connect to, in this particular architecture, corporate data center can connect to private subnet, and public subnet can connect to the internet, right? So and public subnet and private subnet can talk to each other anyways, right, within the VPC using private IP addresses. So there is also another option of connecting private corporate data centers with only private subnet. So this is similar to this arrangement, but minus public subnet and internet connectivity. So this is the fourth option. So let's go ahead and create VPC here. So we are going with an option where we can we are having single public subnet. So if you see this CIDR block, it starts with 16, and AWS recommends that you give the biggest number in the CIDR block, which happens to be 16, and you get somewhere around 65,000 possible hosts which you can place within this VPC. And if you see this, the block size has to be between 16 and 28. So you can't go you know less than 16 and more than 28 here. Okay, so it has to be between those numbers. Let's name it VPC demo. And again, when it comes to public subnets, the default would be 24, and you can go up to 29 if you want 3 IP addresses, and 32 if you just need one IP address. But this is not something which is recommended. So let's go with 24, which means that you have 251 IP addresses available. Though we have 256 IP addresses available, 5 are reserved by the AWS. And yeah, so there is no preference with the availability zones. If you don't want to have any particular preference, you need to select any availability zone. And let's name this subnet as public subnet. We're not going to create any endpoints here, and the DNS host name we have enabled it to yes, which means that it will attach a DNS host name. Using that, you can connect to this particular VPC. So anything, any instance which is deployed will get a DNS host name. So same goes with hardware tenancy. So the default means whatever instance that you run, or whatever instance that you spin up within this VPC will have the default behavior. If you're going with a regular instance, then you will have to share the instance with the host, within the host. And if you're going with the dedicated, then still this VPC will let you have the privileges of the instance. If you go with a dedicated, then it will block any instance which is not a dedicated resource. So let's go with and dedicated resource are chargeable, so be aware of that. So let's go with default and let's create this. Within a moment, you see that all of these components are getting created: subnets, router tables, um, internet gateway, and many more things are getting created. So now it's created. So you see, this is the VPC ID. This is used uh, as an identifier to the VPC. So basically we would be seeing this in while establishing a peering connection and communicating with the VPCs. So this is the CIDR blocker range that we have created. Um, this is a default a CIDR range that it gets acquired. So this CIDR range are mostly private IP addresses. So the private IP address starts with as I mentioned earlier, starts with 10.0.0.0/16 and /8, and the next range starts from 172.16 /12 and 192.168/16. So you can choose any of the reserved private addresses. You can also launch with public IP addresses, but those are not recommended by AWS, since uh, there's a convention followed in the AWS and the outside world about the cider range convention. So it's always a good practice to have a private IP address assigned to the VPC. So we have what we have here is network ACL, which we discussed earlier. So I'm just going to open the network ACL and examine what it means. So here you can see that it is associated with a subnet, and this is a default network ACL, and it is connected to this particular VPC and the owner ID as well. So here you can see that inbound and outbound rules and subnet associated. Let's see what this inbound rule mean. So as I explained in a previous session, the 100 is a number. This is based on number rule, and anything which you add will be executed in the ascending order. So what this rule means is, if the rule is 100 and all the traffic with all the protocols with all the port range from any source is allowed, which also means that any traffic uh, deny will not be applicable, since the 100 rule has given full access to to the network. So this is an inbound rule. Same applies to outbound rule as well. So as I told you earlier, these network ACLs are stateless components. So if a request comes in, and if the request has to uh, go out, or if the request comes in and the response has to go out, um, then both has to be configured. Inbound rules and outbound rules has to be configured to pass through. The traffic has to be allowed in both directions. So you can see there is a subnet associated with it. So subnet is a part of VPC network where instances are launched. Okay, so they also have a cider range with 24 blocks, which we created earlier. So there are 251 possible hosts which can be launched. Here you can see that it is deployed in availability zone 2B. So it is associated with network ACL and the route table. And it also says that auto assign of public IP address is not possible. So we can change that value through actions by modifying the IP addresses through networks. So default is this says whether it's a default subnet or not. So basically we didn't create a default VPC, hence this is not a default subnet. So there is no auto assign of IPv6 addresses here. And let's go and check how route table looks like. Route table, as I mentioned earlier, there are number of routes which are applied or added here, and here we are allowing any traffic which starts with which comes under this network cider range are targeted to local, which means that anything any instance which is part of this network can privately communicate between each other, and everything else will go through internet gateway. So IGW, the prefix basically states that it is internet gateway target. So you can see internet gateway is attached to VPC, which we just created. VPC demo is our our VPC. So let's go ahead and launch an instance and see how we can connect this VPC or how we can place this instance within this VPC. I am going to services and then to EC2. Okay, this is a new interface. I'm gonna switch back to old interface because I never seen that till today. Okay, cancel. I'm gonna check that later. Okay, so let's start with an instance. So there are no running instance out there, no volumes, nothing. So there is one security group created. Let's launch an instance. You get wide range of instances available here. So I would suggest you to pick any free tier eligible instance. So in this case, I'm going to select Amazon Linux option 2 because there are some packages already installed with this. There are also AMIs if you want, if you have created by yourself, or if you want to get an instance from the marketplace, you can spin up these instances. So we will see how this is done in our EC2 sessions. Let's go ahead with the second option. So I'm gonna also pick the free tier eligible instance type. So we are creating only one instance at this moment. We are not going to launch any auto scaling group for this. We are not going to request for spot instances because since we still have a free eligible tier, and we are going to select our VPC demo which we created earlier, or if you want to create a new VPC, we can do that as well, but let's go with VPC demo. We have a public subnet here which is already created earlier. We're going to use that. So auto assign public IP is disabled, but let's go and enable that. So we are not going to add an instance to the placement group. Placement group is basically a cluster of systems that we can have. So we are not going to do that as well. So we're gonna skip through all these options. Accident termination, CloudWatch detailed monitoring. This is again chargeable. Tenancy, we are not going with dedicated instance or dedicated host. So we are gonna go with shared instance or tenancy, and we are not going to enable the unlimited version of burstable instances. So we are going with a primary network interface, and the IP address will be auto assigned. We don't have any preference here, or if you have any, you can actually mention that here. If you don't have, you can just you don't need to add it. For secondary IP, you don't need to add secondary IP here if it is not required. This is a user data place where you can whenever a system is launched, you can add some scripts to run and it would be running only one time for the first time when the system is launched. So let's not do that yet. So probably in these two sessions we'll do all that. So let's go ahead and add storage. Basically this is a root storage device for this instance. I'm just gonna say next. I mean, let's not add any tags here for now. So we are creating a new security group here, and this security group basically states that you can access this particular instance through SSH, and the source can be from anywhere. For now, let it be from anywhere. Probably later we can restrict it even better and try to understand how it works. Well, I'm gonna launch. So we reviewed all this, so let's launch it. So there is a key pair here which is already selected, but let me create a new key pair. I will say it2. So let's download that. Okay, let's download it. Now let's launch an instance. So we have launched an instance, and it will take few minutes to launch, and you can see that you know public IP address has been assigned, and instance is still running. We have private IP address as well. You can see there are security group launch wizards, um, VPC ID, subnet IDs assigned to it. Is this EBS optimized? No. So you can understand what that means as well in the later section. So it is getting initialized. Meanwhile, let me configure the SSH key that we downloaded, right? So let me spin up a new instance. Some time, and what we have is actual A1 PM. So we need to see where that instance is, and we need to set the privileges to it to be accessed. So let me do that background. Okay. Payments and downloads. Okay. Search. Okay. So let's see. IP address, right? So we have to use this. We can just copy here. Okay, so we had the same kind of error earlier. So I just added some privileges. Let's try it again. Okay, so we are in. So the instance is running, and you can see that I have logged into the instance. Now let's see how we can ping this instance and try how it works, whether it works or not. See, I've already copied, right? Ping the public IP. So if you see this, there's a request timeout which is happening. So we need to find out why this isn't working. Okay. Stop this for now. So let's revisit why this is not happening. So first place that we're gonna check is security groups. So if you see here, we have allowed only SSH to be SSH protocol to be accessed alone. So let's add a rule which says to allow ping traffic. So to allow ping traffic, we have something called as ICMP protocol. So it has to be echo request, and we can say pretty much say anywhere, or you can actually restrict from my IP alone. So for now, let's give it more privilege. So inbound traffic basically means from outside I can ping into this instance and check, right? So we don't need to since this is a stateful, we don't need to add any rule here. So let's go back and try this again. So now if you see this, we are able to connect to the ping to the instance. So I'm gonna stop this. So yeah, I mean let's keep running it, it's no problem here. So let's go and visit how network ACLs are placed. So let's go back to the instance here. Let's go back. Okay, it's no. Go back from here. No. Okay, let's go. Sorry. Let's go to VPC. And let's go to VPC. Let's go to network ACL. and we have allowed all traffic here, right? So whether it's an inbound or outbound. um, so let's go and edit the inbound rules. So instead of all traffic, I would say only from SSH probably. Only SSH traffic is allowed now. As soon as you save this, you see here the request is timed out. The reason is it immediately blocks any requests which comes into the which is coming to the network. So let's go and change it back again, revert it back. You can see that it again established the connection here. So network ACLs are very powerful when you want to immediately block any particular traffic which is being hit by your which is being hit to your instances. So if there are any security privileges that you need to add, network ACL is the best place to do that, because it happens at a at a subnet level, and whenever a rule is applied, everything, all instances within subnets uh, get the get this rule applied. So it's a good place to add security privileges. And stop this now. So basically we saw how to launch an instance, how you create a VPC, and how we can ping the instance and some security privileges. Um, we can also one thing I just wanted to show you is in a quick moment I'll just show you that how these rules are prioritized. So since this is, let me add another rule which says rule number 80, which says all traffic I would say deny and save. So you can see that this is blocked. So this is also a place where you can apply deny rules to a particular IP address if you want. So you can go and state here a particular IP cider range if you want to deny. So that is one good option that you could use here. And also whenever you're applying inbound rules, don't forget to add respective outbound rules as well, because these network ACL are stateless.
Uh, Achal, I have one question.
Yes sir, tell.
Can we block a particular IP for certain time during daytime or some few hours, and then you can give the access to that particular host for only for certain time period?
Mm, the, a schedule based firewall is not available here. Probably if you need that, then you might have to use infrastructure as a code option, where you can actually create a network ACL and attach it and do that operation through code. I mean, it's this explicitly doesn't have a feature to do that on the fly. So you have to write, a separate, infrastructure as code capability where it can be automated. Yeah, or it has to be manually done. Yeah, that's a good thing you asked. Cool. Um, Yeah, let's see now. Let's see how an instance, how we can assign elastic IP to it. So let's go and create a, elastic IP. So basically, you cannot ask uh, you know uh, a particular IP address that you need, but the address are allocated by AWS. So if you already own a particular IP, then you can use that here, or Amazon will pick up a particular IP address and will provide it to you. So this IP was allocated to you, and you can use this IP to connect to network interface or instances to communicate. So let's go and attach this elastic IP to an instance. But if you see here, there is also option called release address, which means that you can release this address into the Amazon pool and someone else can pick it up. So elastic IP has to be used very carefully, because if you are uh, asking for the new IP address, and if you are releasing the IP address, and it might be allocated to someone else, and the traffic, a different traffic might be routed to your traffic might be routed to a different application altogether if it is not handled properly. So now I'm associating this address with an instance, and we have a running instance here. So I'm going to attach that to the running instance. Mind that elastic IP address are chargeable if they are not connected to any instance which are running, and also one elastic IP address is free of charge, and if you are creating more elastic IP addresses, it will be chargeable based on hours. It's an hourly charge. So let's associate the address. Let's close this. So it has been assigned to an instance. Let's go and check the instance, how it looks like now. So there is an elastic IP created, and if you see here, our previous uh, IP address range was replaced by the new elastic IP address. So the previous public IP address was released and new elastic IP address was added here. So if you see, this was the previous IP address used, and this is the new IP address which is created. So if you see, there is a request timeout for the old IP address. Let's use this IP address. You can see that with the new IP address, which is public in nature, we are able to establish the connection through ping traffic. Let's now see how IPv6 is enabled. So IPv6 is should be enabled at VPC level. So let's go back to our VPC. Yeah. So if you see here, there is IPv4 CIDR block and IPv6 CIDR block, which says that there is no you know no CIDR block assigned for IPv6. Meanwhile, before we get into the IPv6 creation part, I would like to create a flow log. We had discussed flow log earlier in the session. So basically what it does is any traffic, any request and response that goes in and out is out of VPC can be captured. And let's capture all the logs, all the traffic, and let's send it to CloudWatch logs. So there is no destination log here. So, and also I don't think there is any IAM permission yet. So cloud, there's no permission set up. So let's set up the permission. So we are setting a policy for a flow log role, and it's called flow log role. Okay, it's gonna create, and this is the policy that it is going to create. So logs will have create log group stream and putting the log events and all that. Since now we have a log permission, let's go and create a flow log. So we now have flow log role, and let's add a log group destination. So this log group destination can be part of your CloudWatch log group. So let me say EC2. Okay, I think I need to create that. So let's go to the CloudWatch service. And okay, let's get started by creating log group. Let's say VPC logs. So this is not going to expire. Now we can explore, and there's nothing here. There is no logs available yet. But let's go and use VPC logs and create this. So why I did this exercise is it would take nearly 5 or 10 minutes sometimes to see the logs in the CloudWatch log. So meanwhile, when we are trying to set up the IPv6, the whole CloudWatch log would be ready by then. So let me start. Let me try to ping it. Few more pings would get some logs over there. Okay. I think that should be enough. Okay, now if you are going to edit the CIDR range to add IPv6 CIDR, So we added one IPv6 CIDR here. So there can be only one CIDR block attached to this VPC. So now you see IPv6 CIDR block available for the VPC. Next, what we need to do is we need to go to the respective subnets and create the IPv6 CIDR blocks. So let's go to the subnet part. Okay, let's go to subnet. We have one subnet which is associated with VPC demo. So let's go and basically we need to add any CIDR range that we need. So here let's add 00. That should be fine. So you can see this is the VPC CIDR block, and this would be the subnet CIDR block. When you say 00, it starts from the 00 range. So it starts from the beginning to the next 64 block, 64/64 CIDR block. So we have around 250 available CIDR available hosts, and let's go and modify our EC2 instance to have the IPv6 IPv6 feature or attribute. So let's go to the running instance. I've selected the instance, and we need to modify the network. So if you see here, right now there is no IPv6 IP attached here. So we are going to add the IPv6 address. So we're gonna assign IPv6 address here. So this is basically auto assigned, so it will be picked up from the AWS CIDR range. So it assigned us IP address. So if you need an elastic IP assigned to this, you can do that as well, but since we have already assigned to another address, we are not going to do that here now. Okay, you can see here it has been assigned. So apart from this, you need to handle it in different level as well. That is, we need to handle at route table, we need to handle at network ACL level, we need to handle it at subnet level as well. So let's go and do that. So let's go to this PC. And let's hit the route table. So there are two route tables present as part of this, and let's go and check this route table. So this is associated with VPC demo, and the subnet is this 00FB. We're gonna check what is the subnet that is associated with it. So it is 00FB856 and the same as that. So let's go and change the route table. So you can see that destination or the IP v6 address is already assigned here, but only for the local network. So let's go and add for the internet as well. So let's go and assign it to anywhere, that is the all IPv6 address will be allowed. So here I have to set it to internet gateway. There's only one internet gateway right now. I'm going to assign that and save to routes. Okay. So we configured IPv6 here, and we might have to do the same thing for network ACL and security groups as well. Let's go and quickly add that. So let me add IPv6 rule. So you don't have to select here. In earlier case you should have selected echo request for IPv4. You don't need to do that here. So the CIDR range can be from anywhere. Let's save that. So we have applied the inbound rule to this security group. Now let's go and set the firewall for network ACL. So, you see here another rule has been automatically applied for IPv6 address. So you need to understand that every time you add IPv4 or IPv6, or you want to restrict IPv4 or IPv6, explicit rule has to be added for the respective protocols. So I'm allowing here, and outbound rule is added as well. So we cannot test IPv6 from my system, but there are few resources or online facility where we can do that. Let's do it. Let's say ping. So let's go and ping and test. So let's grab the instance IPv6 address. Okay, I'm gonna place it here and test. You can see that the ping was successful, and 5 packets were transmitted and 5 packets were received. So this basically shows that we have configured all the levels in the VPC to establish IPv6 connection. Now let's go and watch the CloudWatch logs. You can see here the logs within the within the stream. Uh, this is part of log group that we created earlier. So some were rejected, and so the ones which we saw earlier, using for the ping is not available yet. Probably it will be available soon, but it's not available yet. So you can see that what request was accepted and what request was rejected and all that. So basically it's a good place to start looking at if there is any security restrictions or firewall restrictions that has happened, and it basically shows whether the request was blocked or the request was allowed, and so forth. So we basically went through most of the components that were provided by VPC. There is also one more demo that we can do, and that is basically accessing peer connection between establishing a peer connection between two VPCs. So let me quickly create that a new VPC. So I'm going to launch a new VPC wizard. So I'm gonna start with a different site range here. So let's create a VPC and different endpoints, and let's create now. So a new VPC is created, and okay, so let's name this VPC demo _2. And okay, let's start an instance. Yeah. So let's select VPC demo 2, and let's enable this, and we're not going to make any more changes here. Storage tags if you need. Now we're not gonna use any tags as such, but we can create our own launch wizards if you want. Let's create this launch wizard and SSH from anywhere. Okay, it's gonna launch this, and use this which I created earlier. So how are we going to test this is we have to use basically a private IP provided by the VPC, and try to ping from one instance to another and find out whether that is possible to establish the connection. Uh, Meanwhile this is getting created, let's go and check this security group to figure out whether we have a proper rule to make inbound calls for, sorry, outbound call for all traffic is allowed. Okay, that's fine. So we have received a private IP already here. So we're gonna create a private connection between these two instances, which are having a different VPCs attached. So this is having VPC demo, and the next one is having VPC demo 2, and let's do a peer connection to both of them and find out whether it can communicate privately. So let's go and create a peering connection. So we need to go to VPC dashboard and select the peering connections. Let's create a peering connection, and let's say VPC demo. Requester, I would request from VPC demo. Just got both IP address, and I can say that, you know, this is in my same account. The VPC that I'm trying to connect to the same account, and the VPC I'm trying to connect is in the same region. So I'm gonna select acceptor from VPC demo 2. There are two. Requester is demo 1 and requester is demo 2. Let's create the peering connection. Now you see this, there is a successful connection between the two VPC, since the CIDR blocks are not overlapped. If you have a overlapping CIDR block, you won't be able to create these the peering connection. So you can see here that there is a pending acceptance status. So since this both VPCs are in my same account, I might have to go and accept the request. So I'm going to say yes, close this. So now you see this, there's a VPC peering connection established. And we have a two instance running. So let's quickly we already have an instance running here, right? So let's SSH to that instance. Before that, let's ping. Okay, I'm gonna show ping from my system to the private IP address. It's not gonna happen, right? So because it is not part of the network internet. So okay, this is froze now because our IP address range were changed and this was not shut down earlier. So the connection will take some time to close. So let's go ahead and create create open another tab, or we could actually use this same tab to connect. So let's go here and copy this IP address. So this is a public IP address. Yes, connecting to the public IP address. Now let's ping. So the private IP address of this is 10.10.10.0.164, and the private IP address is 10.1.0.11. So let's ping. If you see this, basically the ping is not accepted, so there is some flaw still that we have not there is still something wrong going on. So let's see what that is. One part was when we are creating peering connection is to establish the connection and accept it. The second part of peering connection is recording it in the route table, which we didn't do, right? So we're gonna go and do that now. So let's go and open the route tables. So there are route tables for different subnets, and this is something which we are gonna choose and change. So we have one subnet here, and the route has to be added for the other CIDR block we just messed up. What was the CIDR block of the other VPC? VPC, let's open this. So the CIDR block was 10.10.0.16. So we're going to do that here. Okay, so we have opened the same block. So other was 100.0.0.0/16. So this, any request that comes from this destination has to be routed to peering connection. So browse. Okay. Now let's go ahead and edit the routes for this instance as well. So we need to say 10.1.0.0/16 peering connection, and let's say routes. So now we have established the peering connection. Let's try once again. This is 10.64. Okay. Okay. Let's check the. So there are many moving parts here. So we should be monitoring these subnets and groups and all that. So let's go, and if you see here, we are allowing only SSH for this traffic. So let's edit this and add, let's say, all traffic for now. So if you see that, now the connection was established, and we are trying to communicate between two instances which are two different VPCs, and using private IP addresses.
So you change the outbound inbound rules, right, to all traffic.
Correct. In the security
So
group,
earlier it was only for specific, right?
it was for SSH. Yes.
Yes,
Yeah. So ping traffic has a different protocol. So uh, I should have used ICMP protocol to explicitly allow ping traffic, but I just allowed all traffic to get pass through, so it started working, right? So these are some of the attributes and components that you need to watch through whenever you are trying to establish the connection between VPCs, and setting up the firewalls and so forth. So this concludes the demo, and let's summarize whatever we've learned uh, till now. So VPC, there are many options still out there which you can go and try, and uh, most of the options are free, and it would incur, even if you are using a NAT or VPN, it would charge you in on an early basis. So if you want to try and do that, you can still do, and you will be charged on early, but still it would be less than a few bucks. So let's understand a few VPC limits that are available. So you can create 5 VPCs per region. That's a default limit. It's a soft limit, and you could actually create more as well if by contacting Amazon support, and they would raise the limit. You could create more subnets within the VPC. You can create up to 200 subnets. So even if the CIDR block says you can create up to 256 subnets, or whatever from the VPC, you have a default limit of 200 maximum. Again, these are all soft limits, and some are hard limits. uh, Please go ahead, and I have added a link here. Go ahead and check more about the limits in these section for these particular resources. Okay, so these are some of the very common things that we'll be using, and I've just captured some of them. Yeah. Just wanted to yeah. So yeah, and also one most important thing that you need to see is there are only 5 internet gateways which are available per region. So if you are asking for more VPC, and you need to check the other resources as well for internet connectivity, or net gateways and things like that. So for a VPC, there are no additional charges for creation, but if you want to create a VPN or NAT gateway or that instance, it will be charged on hourly basis. Yeah, so we were discussing about some data which are transferred through internet, right? So we were talking about direct connect, how it can save some cost. If you can see here, per GB they are charging 10 cents when the traffic is routed through internet. So if you're having a direct connection, you can save this cost. Let's do a quick recap of what we learned from yesterday and today. So we've seen that there's something called as default VPC, which was created for every region, as and when you have an account. Okay, so you know, just now we saw a demo of creating non-default VPC. Anything you create is a non-default VPC, and we could have a VPC with private only access. We saw how we could establish, we could associate an elastic IP with an instance, and route the traffic through internet gateway. And there are few steps how internet access from a public subnet can be done here. And we also saw how basically how non-default VPC with a private subnet can be connected to a NAT gateway, not NAT instance. And there are something like Cloud Hub or corporate or home network, which can be connected to VPC using VPN facility. And we saw how IPv6 routing is explicit from IPv4, and any traffic that you need to go through IPv6 has its own configurations to be done in all the VPC components. So we could also, for IPv6 traffic, we could establish an egress only internet gateway, which basically means that your instance in the private subnet can only talk to instances or services which are outside the VPC network, and which would be part of internet, but internet cannot access these instances directly. So yeah, so basically, to summarize the whole thing, VPC can connect to internet from public subnets, and VPC can connect to internet from private subnet with the help of NAT gateway or NAT instances. And you could connect to a corporate data center using VPN, and you could connect VPCs to VPCs using peer connections. You could connect S3 with IP addresses using VPC endpoint. So S3 is a service which S3 and DynamoDB are services which could be done so using gateway endpoints. And you could combine all these connectivity approach and build a different architecture altogether. So yeah, the combination of these architectures patterns can be achieved as well. So we have basically completed all the VPC related discussions. Probably if you have any question, I can take it now. I'm gonna just stop the recording.